Here we solve linear systems by using matrices. It'll basically be the same as solution by elimination, but with basically it's a bit of a shorthand, a shortcut in some respects. So you don't have to carry around a lot of x, y, z's, and equal signs. Starting with a matrix. A matrix is a square array of numbers. For example, here's 1, 3, 7, 0, 17 and a half. It has 2 rows, it has 3 columns. So this is called a 2 by 3 matrix. Whenever you have a linear system, you can write down the coefficients and get what's called an augmented matrix. For example, 1x plus 2y equals 6, 3x minus 1y equals negative 10. We can write this down as 1, 2, 6, here that is. 3, negative 1, negative 10, here that is. This is the augmented matrix for this system. It's called an augmented matrix because it contains a column here, 6, negative 10, for these constants here. We just had a matrix for these 4 numbers, 1, 2, 3, negative 1. I believe that's called the coefficient matrix. Now we can do linear systems by doing the row operations on their augmented matrices. It's the same as before, only we bypass a lot of the carrying around x, y's, and z's. So for example, here we have 2x minus y equals negative 1 and x minus 2y equals 1. So we translate that to an augmented matrix. You get 2, negative 1, 1 here, first row, 1, negative 2, 1 here for the second row. So we'll solve by doing row operations on this matrix. I'll start with this 1 here. I'll pivot on this entry. In other words, use this 1 to clear away this 2. We'll do that by subtracting twice equation 2 from equation 1. So 2 minus twice 1, that's a 0. You can put a 0 here. Minus 1 minus twice negative 2 is 3. So we put a 3 here. And then 1 minus twice negative 1 is a negative 3. So we put a negative 3 here. And we keep the 1, negative 2, 1 in the way it is. So here's the augmented matrix now. 0, 3, negative 3, 1, negative 2, 1. Now this corresponds to the equation 3y equals negative 3. So obviously the thing to do is to divide the first row by 3. Then we get 0, 1, negative 1, 1, negative 2, 1. Well, okay, this will translate back into saying that y equals negative 1. That's nice. And okay, we'll do the equivalent of substituting in here. Here's what we do. We have a negative 2 here and a 1 here, so we add twice. Evolve row 1 to row 2 and see what we get. 1 plus twice 0 is a 1, so there's a 1. Negative 2 plus twice 1 is a 0, so put a 0 here. And 1 plus twice negative 1 is a negative 1, so put a negative 1 here. Now, for reasons of neatness, what we do is we swap rows. So we get a diagonal, 1, 0, 1 here. And then we have negative 1, negative 1. And when you translate back, this becomes x equals negative 1 and y equals negative 1. I did this swap because otherwise we get y and then x. I want to have them in alphabetical order. So you use row operations to get a matrix of the form 10a, 01b, which translates back to x equals a and y equals b. All right, here we go. X plus y equals 2, x minus y equals 0. Solve that. Well, okay. We translate to 1, 1, 2 here. 1 minus 1, 0 here. Let's do row operations on this. I'll start with this 1, pivot on this one, i.e. eliminate this. To do that, we take 1 minus this. So you take this row 2 and subtract row 1 from it. 1 minus 1 is a 0, so there's a 0. Negative 1 minus 1 is a negative 2, so put a negative 2 there. 0 minus 2 is a negative 2, so we put a negative 2 here. Okay, here's the matrix now. Now, this corresponds to negative 2y equals negative 2. So the thing to do is divide throughout by a negative 2. So we scale that row by a negative 2. And that becomes 0, 1, 1. So the matrix is now 1, 1, 2, 0, 1, 1. Okay, we can pivot on this entry here. I clear out its column. So to get rid of this, we take this row 1 and subtract row 2. 1 minus 0 is a 1, so the 1 goes there. 1 minus 1 is a 0, so put a 0 in the middle there. And 2 minus 1 is 1, so put a 1 there. So you have the matrix 101, 011. This translates to x equals 1. This translates to y equals 1. 1 by 1. And it makes sense. 1 plus 1 is 2. 1 minus 1 is 0. Here we have the system x minus 3y is 9, and minus 2x plus 6y is 18. So 1, negative 3, 9, first row. Second row is negative 2, 6, 18 for the second row. All right. These all have a factor of 2, and in fact, I'm going to divide the row by negative 2. So we get 1, 3, 9, 1, negative 3, 9, and the second one is 1, negative 3, negative 9. All right, let's pivot on this. To get rid of this, we'll subtract row 1 from row 2. 1 minus 1 is a 0. There's a 0. Negative 3 minus negative 3 is also a 0. There's a 0. Negative 9 minus 9 is a negative 18. Negative 18. Uh-oh, we have a problem. This last row corresponds to, translates back to 0 equals negative 18. An absurdity, therefore the original equation was absurd, and therefore there's no solution. So this is an equation system without solution. Ah, 3 by 3. Oh, 2 3 by 3s actually. X plus y plus z equals 6. X plus 2y plus z equals 8. X plus y plus 2z equals 7. So 1 1 1 6, first row. 1 2 1 8, second row. 1 1 1 1 1 2 7, third row. Now I'm going to pivot on this entry, i.e. we're going to clear away the rest of its column. So the second row will subtract first row. The third row will subtract row 1. And all right, so first row, just put it back, 1 1 1 6. The second row, let's see, 1 minus 1, that's a 0, so put a 0 there. 2 minus 1, that's a 1, so we put a 1 there. 1 minus 1 is a 0, so we put a 0 there. And 8 minus 6 is a 2, so we put a 0 there. Already we can see that y will equal 2. For the third row, 1 minus 1 is a 0, so we put a 0 there. 1 minus 1 is a 0, so we put a 0 there. 2 minus 1 is a 1, so we put 1 there. And 7 minus 6 is a 1, so we put a 1 there. Now, all right, this corresponds to saying at y equals 2. This says z equals 1. And okay, what I'm going to do is I'm going to eliminate both of these ones by subtracting row 2 and row 3. The zeros here and here won't change it. So here we go. 1 minus 0 is a 1. 1 minus 1 minus 0 is a 0. 1 minus 0 minus 1 is a 0. 6 minus 2 minus 1 is a 3. So we get this matrix. 1003, 0102, 0011. And translating back, that's x equals 3, y equals 2, and z equals 1. 3, 2, 1, that's the solution to this system. All right, this one, this first step of translating to a matrix is a little tricky because you have to put in spaces where the variables are missing. 5x plus 3y equals 4. Well, there's 0z here, so we really write this 5, 3, 0, 4. The 0 for the 0z. 3y minus 4z is 4. Well, there's 0x, so we have 0, 3, negative 4, 4. And x plus z equals 1. There's no y, so 1x, 0y plus 1z equals 1. 1011. All right. Let's see. Here's what I'm going to do. To cancel out this, I'm going to pivot on this entry here. So there's no need to clear, that's already cleared away. But this, okay, is a negative 4, so we have to add 4 times this 1 in row 3. So add 4 of row 1 to row 2. So 0 plus 4 times 1, that's a 4. It goes there. 3 plus 4 times 0, that's a 3. It goes there. negative 4 plus 4 times 1 is a 0. It goes there. And 4, oh dear, 4 plus 4 times 1 is an 8, so an 8 goes there. All right, now, it's going to be really convenient actually here of a 5 and a 4, a 3 and a 3 and a 0 and a 0. So if we subtract row 2, 5 minus 4 is 1, 3 minus 3 is 0, 0 minus 0 is 0, 4 minus 8 is negative 4, and we already have the equivalent of x equals negative 4. Now, okay, here we're going to use this to pivot away these. We have 4, we're going to subtract 4 of that. Here's a 1, so we'll subtract this 1 of that. So row 2 minus 4 times row 1. Well, okay, 4 minus 4 times 1 is a 0. 3 minus 4 times 0 is a 3. 0 minus 4 times 0 is a 0. And 8 minus 4 times negative 4, it works out to a 24. And here we just subtract row 1 from this. 1 minus 1 is a 0. 0 minus 0 is a 0. There. 1 minus 0 is a 1. And 1 minus negative 4 is a 5. We're nearly done. This row corresponds to saying 3y equals 24. So if we divide throughout by 3, the second row becomes 0108. The first row is still 100 negative 4. The last row is 0015. So here we have this matrix. And then you translate that to the equation. You get back x equals negative 4, y equals 8, and z equals 5. Negative 4, 8, 5. Done here. We'll check. Okay, that concludes that. All right. Stop recording.